Get strong.
Hi, welcome to my channel. My name is Lorenzo. If you wish to unpack the facts about different types of triangles and their relationships and some basic calculations related to the triangles, then this is the right channel for you. Today I'm going to explain in detail the classification of triangles, the relationship among each type of triangle, and do some basic calculations. So let's get started. The general definition of a triangle is categorized into two major categories. That means based on its size and based on angles. So let's first see classification of triangles based on sides. Alright, the first type of triangle that we're going to see, equilateral triangle. Equilateral triangle is actually, it's a triangle that has all three sides are equal in length. That means you're going to see here, that means side AB should be is equals to side BC should is equals to AC. Alright, so equilateral triangle has got three equal sides. That's one thing. What's another property of equilateral triangle? Well, equilateral triangle has got three internal angles which are also equal. Because of that, sometimes equilateral triangle is it's called equiangular. That means we can say angle alpha is equals to angle beta is equals to theta. So what else is the third property of equilateral triangle? Well, not only this, the angles are equal, the internal angle of all the three angles of equilateral triangle are 60. To start with, by definition, the sum of the internal angles of any type of triangle is 180 degrees. Alright, let's do this. That means alpha plus beta plus theta must be equal to 180 degrees. Okay, in our previous discussion what we said is alpha is equals to b, beta is equals to theta. That means equilateral triangle has got three sides equal and also three angles are equal. I will tell you the tip that you can easily understand why the three sides are equal and why the three internal angles are equal. So let's first do this proof that all the angles of equilateral triangle are 60 degrees each. Alright, we have the summation of the three angles of any triangle is 180 degrees, and also each angle are equal. That means we can say this is, let's say alpha is equal to b, beta is equal to theta. Let's say this is the value of x. Let's assume each of them have got value of x. So if we substitute x here, 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 what we'll get is actually 3x is equals to 180 degrees, because this is x plus x plus x gives us 3x. So dividing by 3 both sides, we will have x is equals to 60 degrees, which means alpha is 60 degrees, beta 60 degrees, and theta is 60 degrees. That's beautiful. Alright, how do we calculate the area of this triangle? area of any triangle can be calculated by a formula, half times base of a triangle times height of a triangle. Alright, which one is the base of equilateral triangle? The base is actually, this is the base of a triangle, BC. So base is BC times, alright, what's the height of the triangle here? Alright, the height is not given, but we have to find the height in some way. So how do we find the height? Let's start from vertex A all the way down a straight line, which makes 90 degrees to the base. So that is our h value. That's our h. So this is how we calculate the area of equilateral triangle. What about the perimeter? Perimeter P is equals to the summation of all sides of a triangle. That means side this plus side BC plus side AC. That means side AB, sorry, it's the same, side AB plus side BC plus side AC. This is the perimeter of an equilateral triangle. Alright, the second type of triangle based on the sides of a triangle is isosceles triangle. This is isosceles triangle. What is an isosceles triangle? An isosceles triangle is actually a triangle with two sides equal. Alright, so if you consider A is our vertex of this triangle, AB and AC must be equal, which means AB must be equals to AC. Alright, this is one property of isosceles triangle. What is the second property of isosceles triangle? Well, if these two sides are equal, opposite angles to this side must also be equal. Alright, what's the opposite angle of side AC? The opposite angle of side AC is beta. That means beta must be equals to, the opposite side of AB is theta. So beta must be equals to theta. Alright, so the two angles are equal and two sides are equal. In equilateral triangle here, what we can say is actually, if the three sides are equal, all the angles opposite to each of the sides must also be equal. That's why three sides of an equilateral triangle are equal, and all the opposite angles to each of the sides are also equal. Alright. So, how do we calculate the area of equilateral triangle? The area of equilateral triangle can be calculated as follows. Area A is equals to half times base of a triangle times height of a triangle. This is the general formula for any triangle. Okay, so I'll tell you why it's called half base times height. Alright, so we know that base of this triangle is BC. What about the height? The height is actually, we can still draw straight line from vertex A all the way down to here to the base, and that makes 90 degrees, which is perpendicular to the base. So this is H. This is the area of a triangle. What about the perimeter? The perimeter is actually P is the summation of the sides of the triangle. Okay, so AB plus BC plus AC, AB plus BC plus AC. All right. Okay. The third type of triangle, based on sides of a triangle, is actually a scalene triangle. A scalene triangle, which is one of the properties of the scalene triangle is actually none of its sides are equal, which means side AB is not equal to side BC is not equal to side AC. So from this you may already understand that none of its angles are also equal. If the sides are not equal, the angles are not also equal. That means angle alpha is different from beta, is different from theta. All right. So this is for triangle. So how do we calculate the area? It's just the same for this one. Area A is equals to half times base of a triangle times height of a triangle. All right. So half times base is let's say this is BC is a base. Side BC is a base of a triangle times what about a height? As usual, we can draw from vertex A all the way down, and this makes 90 degrees to the base, and we can call this as H. So that's our H. All right, that's the area. All right, so similarly, perimeter P is summation of all the sides of a triangle, which is AB plus AC plus BC. AB plus BC plus AC. Okay. So these are basic calculations of any type of a triangle. Okay. That's an area of each of the type of area. Area of any type of triangle. One more thing what I want to mention here is actually why is the area of a triangle described by half base times height? Let's assume this is a triangle. Let's see, this is a triangle with A, B, and C. That means this is base, that's height. Okay. So what you can see is actually, I will take this one quickly. Sorry. So if you draw like this, you'll find a rectangle. So the area of rectangle is actually of a rectangle is equals to base times height. Base times height. Okay, that means BC times AC. So this triangle is half of a rectangle. That means triangle is half of rectangle. Okay, so that's why the area of a rectangle is halved and then becomes the area of a triangle. Okay, So that's half times BC times AC. This half is coming from the idea of half of the rectangle area. Okay, let's go to the second classification of triangle based on angles. The second type of classification of triangles is based on the internal angles of the triangle. The first classification is acute angle. This is acute angle. The second type of triangle based on angle is right angle triangle. Right angle triangle. And the third one is obtuse angle triangle. Angle triangle. All right. So these three types of triangles have got their own properties. So when we see acute angle triangle, acute means actually it's less than 90 degrees. So all the angles are less than 90 degrees. Alpha, beta, and theta are all less than 90 degrees. Alpha 90 degrees and beta is less than 90 degrees. All right. So the sides may not be equal or may be equal. The angles also, they may be equal or they may not be equal, but all the angles are less than 90 degrees. So the typical acute angle from our previous discussion is actually equilateral triangle, because equilateral triangle has got 60 degrees of angle, equal internal angles, and because of that it's typical acute angle triangle. The second type of acute angle triangle can be isosceles triangle. An isosceles triangle, as I said, two angles are equal and two sides are equal. If you consider this as a vertex of a triangle, side AB and side AC are equal, and also the angles opposite to these sides, that means beta and theta, must be equal. So an isosceles triangle can be acute angle triangle because all the angles of isosceles triangle are also less than 90 degrees. Okay. The third type of acute angle triangle can be a scalene acute angle. That means acute angle can have different sides. They may be different in length, and also the angles may be all different, but all of them less than 90 degrees. So acute angle triangle can be a scalene angle triangle, it can be isosceles angle triangle, it can be equilateral angle triangle. The second type of triangle based on angles classification is a right angle triangle. So the right angle triangle is a type of triangle that has one of its angles is equal to 90 degrees. So one of its angle is 90 degrees. Okay. Usually this height is called it's a height or leg. Height or leg. This is base. And the third side is hypotenuse. Hypotenuse. Okay. So on right angle triangle, one of its internal angles is 90 degrees. That means based on the rule of all the internal angles should sum up to 180 degrees, alpha and theta must be 90 degree. So alpha plus theta must be 90 degree. All right. So right angle triangle is a triangle with one of its angles equal to 90 degree. So the third side, Pythagoras theorem can be applied only for right angle triangle, which is side AC square is equals to side AB square plus side BC square. So this rule only applies for right angle triangle. Okay. The third type of triangle based on angles classification is actually it's obtuse angle triangle. What's an obtuse angle triangle? It is a triangle with one interior angle greater than 90 degree. So as you can see, one of the angles is greater than 90 degree, which is beta. Beta is always greater than 90 degree. So beta is greater than 90 degree, which means from the rule of all the internal angles must sum up to 180 degree, what we can obtain is alpha plus theta should be less than 90 degree. Okay, if beta is so the longest side, which is AC, is the side opposite to the obtuse angle. That means the longest side AC is the side opposite to the largest angle, and the smallest side is a side opposite to the smallest angle. All right, so the largest side is a side opposite to the largest angle, and smallest side is a side opposite to smallest angle. Okay, so an obtuse angle triangle cannot be a right angle triangle, because in a right angle triangle one of the side angles is 90 degree, but in obtuse it's greater than 90 degree, so it cannot be a right angle triangle. Okay, so an obtuse angle triangle can be a scalene triangle, which means it may have different sizes. All the three sides can be different, which is scalene. Or it can be an isosceles triangle. That means this side and this side, which means AB and BC can be equal. But it cannot be right equilateral triangle, because in an obtuse angle triangle, one of the sides is the longest side, so it cannot be an equilateral triangle. So how do we calculate the area of each of the triangles? It's very similar to the previous one. So area of an acute angle triangle is half times base times height. So half times base is actually BC, so that's the base, and height is, we can draw a straight line all the way down 90 degree, which is, we can say this is H, so times H, that's an area of an acute angle triangle. Perimeter P is equals to summation of the three sides, AB plus BC plus BC, AC, sorry, AB plus BC plus AC. All right, what about the area of right angle triangle? Is still the same, so we can still use the same formula here, which is area is equal to half of base times height. So in this case, half of base is BC and height is AB already. So AB, because they are already perpendicular to each other. so we don't need to draw the straight line from the vertex all the way down to the base. So the area of an obtuse angle triangle can be calculated similarly as A is equals to half of base times height of a triangle. So half of base is actually BC times, here we go, what's the height of this triangle? The height of this triangle is actually, we can draw a straight line from outside all the way to the base and right angle. So this is H. So that is H. So in an obtuse angle triangle, the height can be drawn from outside because it's an obtuse angle which is greater than 90 degrees. The vertex is leaning towards outside of the triangle, so we have to draw straight line from the vertex all the way down to the base. That's the height of the triangle. So this is the end of the discussion of different types of triangles and their characteristics. Thank you for watching my video. Please subscribe to my channel and let's grow together.